This is an introductory tutorial to D+, a solution X-ray scattering data analysis software programmed and tested by Avi Ginsburg, Tal Ben-Nun, Asaf Shemesh, Lea Fink, Roi Asor and Uri Raviv's research group at the Institute of Chemistry in the Hebrew University of Jerusalem. In this tutorial we shall show you how to install and run a simple calculation on D+. As you can see, the installer is a regular Windows installer. Select the folder in which you want to install D+, and press Next. Once D+ is installed, you can open it from the Start menu shortcut. The workflow in D+, starts by defining a structure. The appropriate computation parameters should then be selected, and then the computation can be performed. We shall now show you how to calculate the scattering intensity of a simple geometric model. Our model, in this case, is uniform hollow cylinder. In the 3D graph pane, you can see the real space representation of the object you wish to calculate. You can control the view angles and zoom level, either from the 3D graph itself using the mouse wheel, or from the controls panel at the topmost right panel. Another important manipulation of the 3D view is the level of details. You can see it on the Preferences panel, which is the second panel from the top on the right side of the screen. High level of details provides a more accurate 3D representation, but, especially with large objects, can significantly slow down the graphical interface. The level of details does not affect the calculation time or accuracy. It causes the representation to look better and react slower. We shall now calculate the scattering intensity from our 15 nanometer uniform hollow cylinder. Switch to the 2D graph and click Generate. As you can see on the log scale plot, there are some numerical issues with the calculated curve. To get better results, you can try to use our accessory tool called Suggest Parameters. From the Settings menu, open Suggest Parameters to get better idea what parameters to use for the calculation. In X, Y and Z fields, you should enter the largest distance within your object, in each axis. In our hollow cylinder model, in X and Y, the largest distance is the diameter of the cylinder. In the Z-axis direction, the largest distance is the height of the cylinder. In the Q-max field, you need to put the maximum value of the magnitude of the scattering vector, Q, which you want to calculate. The units of Q are inverse nanometers. The program suggested a grid size of 110. We now return to the D+ program itself. Enter the grid size of 110 that was suggested, and click Generate. This didn't make a very big difference in the results. So you can go back to Suggest Parameters and look at other suggested parameters. One of the important parameters is convergence. The suggested convergence is lower than the one that we have used. So to get better results, we enter the suggested lower convergence value, and click Generate. The result looks much better. The next parameter to look at is the maximal number of integration iterations, called integration iterations. The suggested number is higher than the number we have used, so we modify that number as well, and click Generate. In general, lower convergence and higher integration iterations lead to more accurate calculations, but cost in longer computing time. So this is a balance you need to consider. The last important parameter to look at is integration method. In this case, Suggest Parameters recommended to use Gauss-Kronrod. This method is adaptive and is recommended when one of the dimensions is significantly different than the other two dimensions, as in our cylinder. We go back to D+, and select Gauss-Kronrod under Integration Method, and click Generate. Now, we get a much smoother scattering curve. Here we load an analytically calculated scattering curve of the same cylinder, computed by X+, a software developed in our research group a few years ago. As you can see, the result of X plus perfectly matches the result of D plus.